at tonight are transformations. And the idea of transformations is that when we think about our canonical functions, their canonical functions are sort of placed in specific locations, usually centered at the origin. So just to kind of go over some of those, we've got, say, y equals x. Another one, y equals x squared. And another one, y equals x cubed. We have this one. Y is the absolute value of x. Y is the square root of x. And this is probably the last canonical function. Y equals the cube root of x. And these, for the most part, are centered down the origin. Like this one here, okay, it originates from the origin. 0, 0 is a point for this one. Better emphasize that. There we go. So, okay, that's great, but what if we want these functions to be moved around? Like we want the parabola y equals x squared over here. We want to take absolute value of x and raise it up a little bit. Maybe we want to squeeze them in or pull them apart a little bit, stretch them out. Well, that's where transformations come in. Sometimes when we're trying to come up with a mathematical model, not all of our data, for modeling data, or for looking at a mathematical relationship, they're not all going to be centered about the origin or originating from the origin. So if we're going to use some of these functions to represent relationships in the real world, we want to be able to shift them around. So that's what we're going to look at tonight. Let's see here. I have my eraser somewhere. Oh, here it is. So first off, vertical shift. Now let's consider a number c greater than 0, some constant greater than 0. So this could be 1, 2, 3, 4, a half, something like that. But it's not 0 and it's not negative. So if we want to shift a function up by c units, well, what we do is we take our original function and we just add c to it. And that's it. That'll shift it up c units. If we want to shift it down, well, we start with our original function and we subtract c. And that's it. So what effect does this have on the graph? Well, if we think about the ordered pair, x, f of x. Well, shifting up so this represents shift up, little abbreviation. If we're going to go up by c units, that means going to replace x comma f of x with x comma f of x plus c. And if we're going to shift down by c units, well then x f of x, that becomes x f of x minus c. So what this means, this coordinate, what we call the y coordinate or the f of x coordinate, to shift up, we just add c to all the f of x or all the y coordinates. Just add c to them. And since the y coordinate tells you how high you are along the y-axis, well, adding c will raise everything up, c units. The same thing here, if your f of x is, say, here, and you take c and subtract it from all the y coordinates, everything drops down by c units. So let's take a look. So y equals x squared. And let's raise this up 2 units. So let's take a look at this numerically. Here's x, f of x, f of x plus c. So this will be our f of x. Y coordinate f of x, they refer to the same thing. So let's say we have -2, -1, 0, 1, and 2. So f of x, well, that's going to be f of -2. We're squaring -2, we get 4. Square -1, we get 1. Square 0, 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. Now, we actually did have a number for c. It was 2. So if we're going to shift everything up by 2 units, we're not going to change the x's. Those are going to stay the same. But f of x, we're going to add 2 to it. So we get 4 plus 2 is 6. 1 plus 2 is 3. 0 plus 2 is 2. 1 plus 2 is 3. 4 plus 2 is 6. So what this means, we come up with our ordered pairs. We usually have -2 and 4, -1 and 1, 0 and 0, 1 and 1, 2 and 4. But now the ordered pairs will become -2 and 6, -1 and 3, 0 and 2, 1 and 3, 2 and 6. So I'm going to graph both sets of ordered pairs. So if we start at -2, if you just square -2, you get 4. Look at this. You square -1, you just get 1. You square 0, you just get 0. You square 1, you just get 1. Square 2, you just get 4. So this is without the transformation. So we connect these. Off we go. Now, the new ordered pairs, we take whatever the y value was and we add 2 to it. So if you remember, -2 wasn't paired with 4 after the transformation, it was paired with 6, -2 and 6. We add 2 to the y value, this. Add 2 to this y value, 3. Add 2 to that y value, 0 plus 2 is 2. Y value of 1 now becomes 3. Y value of 2, well, sorry, not a y value of 2, y value of 4 at x equals 2. Again, we don't do anything with the x values. We're just working with the y values. So y value of 4 now becomes 6. And if we connect the dots, that's what we're going to get. Every point is shifted up by 2 units. If we subtracted 2, instead we would drop everything by 2 units, drop this by 2 units, drop this by 2 units. Same thing here. We drop this by 2 units, we would drop this by 2 units, and that would shift it down. So that's the idea of a vertical shift. We're just adding something or subtracting something from the y coordinate. So horizontal shift. Now this one's a little peculiar, but again, we'll start with a c greater than 0. And it works like this. Shift right. So we're just taking our function and we're sliding it rightward along the positive x direction. Oddly enough, say from an aesthetics point of view, that means we take f of x and we have x subtract c. Not add it, just subtract it. Now, what I want to talk about here is we're still actually not modifying x. We're still putting x in, like say 3. But then what happens is when the input goes into this function, we subtract c from that 3. So yeah, I'll show you what I mean. But for a shift left in the negative x direction, you may have guessed it, f of x plus c, again, seems kind of counterintuitive from an aesthetic point of view. If you're going in the positive x direction, we're subtracting. If you're going in the negative x direction, you're adding. But that's just the way it is. All right. So let's look at an example. Again, let's look at our friend f of x is x squared. And again, let's go as c being 2. So c is 2. So we have x, f of x, and f of x minus c. Let's shift this to the right. What happens? Well, again, let's go with -2, -1, 0, 1, 2. Well, in fact, let me make a change here. Let's let c be 1, just so we do the graph, it'll fit on the board better. Well, again, f of x means whatever x is, we're We're going to square it. Square negative 2, we get 4. Square negative 1, we get 1. Square 0, we get 0. Square 1, we get 1. Square 2, we get 4. Now, when we subtract c, and again, we have a value for c, it's going to be 1. X is going to be the same. We're still having x be negative 2, negative 1, 0, 1, and 2 as the x coordinate in the ordered pairs. That's not going to change. What is going to change, though, is when x jumps in, before it goes into the computation, we're going to subtract 1 from it. And to emphasize this, I'm going to record the ordered pairs just to show that those aren't actually being changed. The x's are still going to be the same, but the input's going to get altered. So what ends up happening, we'll get f of negative 2 minus 1, which becomes f of negative 3. Because negative 2 subtract 1 is negative 3. Square that, you get 9. F of x negative 1, it's going to be negative 1 subtract 1. And that's going to be f of negative 2. So if you square negative 2, you get 4. And here, let me rewrite this so there's no confusion, less confusion, hopefully. Negative 2 minus 1, f of negative 3, and that gives you 9. So the actual x we put in there is still going to be this, but the input does get modified into that. But when it comes to our x coordinate, it's still going to be negative 2. Still going to be negative 1. For 0, f 0 minus 1, which is f of negative 1, square negative 1, you get 1. Oh, 0. Yeah, I got to be careful of that too. There we go. So for x is 1, f of 1 minus 1, or f of 0, which is 0. Square 0, you get 0. And this one, f of 2 minus 1, which will be f of 1, square 1, you get 1. All right. So if I just check my math here, make sure I didn't make a mistake, it's easy to do. Okay, it looks good. So what are we looking at here? Well, the original ordered pair was negative 2 and 4, for example. But now with the shift word right, you have negative 2 and 9. Original ordered pair, negative 1 and 1, has now become negative 1 and 4. 0 and 0 has now become 0 and 1. Notice how the x coordinates are still here. It's that y coordinate that's changing, but this time it's changing because we're modifying the x just before it jumps into the calculation. Or the input, I should say, or modifying the input. The x itself actually stays the same, and then we have this modification of the input. 0 to 0 is now 1 to 1, 0 to 1. 1 and 1 becomes 1 and 0. 2 and 4 becomes 2 and 1. So let's graph this. We'll see what this looks like. Let me just check this math again. I just want to make sure. Okay. All right. So let's take a look. So if you graph these ordered pairs, you get a little more room. So the original curve at -2, 4, -1 and 1, 1 and 1, 2 and 4, and then 0 and 0. We're going to get this. Now, if we graph the other ones. So we had -2, subtract 1 was -3. Square that, you get +9. -1 subtract 1 was -2. Square that, you get 4. One minus 0 is -1. Square that, you get 1. 1 minus 1 is 0. Square that, you get 0. 2 minus 1, square that, you get 1. And let me throw another one in there. Let's say we have x equals 3. That means f of x, which is f of 3, become 9. And then f of 3 minus 1, because now we have x minus 1. F of 2 is, well, 2 squared is 4. So when x is 3, we're going to get 4. Now on the original plot, when x is 3, f of x is 9. So put that up here. But here, when f of x is 3, we get 4. Or when x is 3, we get 4. And then you modify that 3. Or the input, I should say, the 3 itself stays the same. But the input to the function won't just be 3. It'll now be 3 minus 1. If we connect these dots, what we end up getting is this point's moved over here, this point's moved over here, this point's moved here, this point's moved here, and this point's moved here. So the point that used to be over -2 is now over -1. It's moved over to the right 1 unit. The point that was over -1 is now over 0. It's moved to the right 1 unit. The point at 0 is now at 1. It's moved over to the right 1 unit. And then the point at 1 here is now over 2. It's moved 1 over to the right. So that's the idea. If we want to shift to the right, we subtract by that many units. We put that inside our f of x. If we want to shift to the left, we add. All right, so those are the horizontal and vertical shifts. Any questions? Let me know.